thought you wouldn't because
Yeah, right, yeah. Non-fiction, but
Yeah, I've never been chosen.
I was.
Yeah, how long ago?
but it was.
Like a full-on trial.
One sec, I'll look it up.
Yeah,
Because Merlin can do that for us.
$5 a day.
Actually, that was interesting that you published it through
Something ridiculously low.
Maybe more in line with Minnesota's publishing specialties.
Yeah.
Deconstruction machines, writing in the age of cyber war.
With your lecture,
Currently on order,
you get scheduled.
and then it'll be on hold, and then it'll be checked out.
You're allowed
Or requested, I guess is how it appears in the system. So.
Yeah. Besides which they might not need you then.
Right, then you get wrong.
The people who draw voice.
All right.
Acquisition time. Here's my little observation. People that compete in the most efficient time. We're all playing.
Yeah.
Just the way humans are constructed.
Yeah, I'm habitually early to things, so it definitely threw me off when I first got to Michigan.
Right. Yeah, that's not a really common thing around here.
Yeah, I've noticed.
And it doesn't really matter, right? It's completely arbitrary where you decide.
Yeah.
As long as you all agree, that's really,
Yeah.
otherwise it doesn't matter.
Exactly.
Obviously, it's going to be an hour off next week. That's the greatest trick in the book. They'd be like, oh, it's just the 1 hour. But, no, it's an hour earlier every day.
Yeah, it will be very interesting.
All right, welcome everyone to the Tools and Technology Seminar Series. I appreciate everyone coming during spring break. It's so nice and quiet in the hallway. It's very nice. But it seems like a perfect time to have an interesting talk. So there's a sign-in sheet going around. As always, please remember to sign it. I'm pleased to present today's speaker, Matthew Flickinger. He is a senior applications programmer for the Center for Statistical Genetics in the School of Public Health.
All right, thank you. Yes, so as was already mentioned, I am an application programmer in the Center for Statistical Genetics. I got my PhD here in the Biostatistics Department at the University of Michigan, working with Drs. Banky and Gonzalo on methods for detecting DNA contamination in sequencing studies, which is also interesting. But in writing my dissertation, I didn't like the writing part very much. So I liked distracting myself, and I found that I started answering questions on Stack Overflow for R. I felt like these little wins I could do every day instead of trying to do one giant document. So I got a little carried away with that. So according to Stack Overflow's own little statistics, like the answers I posted have reached over 2.7 million people, which is just like page views from search engines. I'm not sure how many people actually found that useful, but I've answered a bunch of questions, and it helps me kind of stay sharp and just interested in how R works. So today's talk is about the Dplyr package, specifically in R. So I'm going to assume that you're already kind of familiar with R. I'm not going to try and sell you on R or anything like that. But if you haven't been using Dplyr, I'm just going to try and maybe show you, and even if you have, I'll try and show you a few features why you would be interested in it, and maybe a few features that you haven't used of it, just to make your lives wrangling data a little bit easier. So data scientists spend a lot of time just manipulating data, wrangling it, summarizing it, cleaning it, creating summary statistics about it. And those steps just, while they're so common, it's also nice to have just a very easy language to like express what you're trying to do in it. And Dplyr kind of helps give you these like kind of basic building blocks to make a very expressive kind of procedural analysis plan. Now, base R is perfectly fine for many of these tasks. So if you've been using R for a long time, you might think like, why do I need to bother with Dplyr? I can do all these same things using square brackets and dollar signs and stuff like that. But I just find that the syntax can kind of be maybe verbose or a little bit ugly with old style stuff. And it can also be kind of slow for big data. A lot of the functions in Dplyr actually do have accelerated kind of C level counterparts that it can actually just run faster using Dplyr commands. So Dplyr just exists to make code easier to read, and hopefully it's primarily not a speed improvement, but it does make it a little faster. So Dplyr is one package in this so-called Tidyverse collection of packages that is becoming very popular in R. So I'm not sure if you've familiarized yourself with it, but from the description of the Tidyverse page, it's just a collection of opinionated collection of R packages designed for data science. So they all have kind of like similar looks and feels in how they describe their parameters, how they work together, how things like chaining work. So they're all kind of a collective bunch, and they all work very well together. So it's almost like a new layer that's kind of built on top of base R, just to make a lot of common tasks easier. And Dplyr is kind of like the data wrangling, the data manipulation part of that. And I just bring that up because the Tidyverse is very popular, and it is gaining traction. And it's also, I do teach beginners R. I also find it's actually a very useful way to introduce people to R and doing the types of tasks that you do in R. So if you are also going to be teaching others how to use R, there's a lot of great advantages talking about why teaching Tidyverse first just helps make people more productive right away. So this is kind of designed, if you do want to type these commands along as we're going today and you happen to have a live laptop in front of you, you're welcome to do that. And if at any point, I do have our studio open. So if you want to see me type things because you want to see, you have a question about how something works, I'll be glad to demonstrate any of those for you as well. So feel free to ask. So you can either install just Dplyr, or you can install all the Tidyverse packages at once. It is a lot of packages grouped together. It's kind of if you're in a fresh R install, it is a lot of things it installs once, but hopefully that means you don't have to install many other packages ever again later, or you can just install Dplyr directly. A lot of the specifics, some of the syntax is changed a little bit from older versions. All the things I'm using in this slide are from 0.7.1, which has been around for a while now, since June of 2017, but just make sure your Dplyr version's up to date if any of the code samples don't work here. There are new versions of Dplyr as well, but not much has changed significantly since then. And for all the slides, I'm going to be using example data from this NYC Flights 13 data, or it's a package, and it basically has a few tables that contains a bunch of flight information about all the flights that left New York City in 2013. So it just has some sample data to work with for all these tests. So you just install the package and you load it, and it's available to you. So this is the primary table that I'm going to be working with for most of these examples. It's called the flights table. It has information like month, day, year, the departure time, the actual departure time, the scheduled departure time, departure delay, arrival time, things like that. And also, you know, this printout looks a little different than a normal data frame does in R. It's actually what the Tidyverse world calls a tibble, which acts a lot like a data frame, and it just stores data. But instead of like, if you have a very big data frame, it can like take over your console if you type the name of the thing. This just kind of clips it out a few lines and just wraps the columns that it can't display there. So it's not just these columns. There's also flight numbers, the distance that was traveled, the time in air, things like that are all in this table as well. So that's just the sample data we're working with. So the kind of the fundamental building blocks of Dplyr are these kind of single table verbs. So it has a bunch of kind of, again, just useful verbs that you apply to your data to get results. So there's things like filtering, so that just keeps a subset of rows. Selecting chooses a particular set of columns that you're interested in. Arrange is the Dplyr verb for sorting the rows in your collection. Mutate allows you to create new columns. Summarize allows you to create columns by collapsing information, basically summarizing across groups and creating a new calculated value from that. And then there's grouping by, which allows kind of you to say, I want you to logically perform these operations in these groups of data values at a time, and either summarize or mutate within those collections without having to do a bunch of subsetting or something like that yourself manually. So I'll start showing how these, well, I should say, all these verbs have a similar property in that they always take the data source as the first parameter, so some sort of data table or a data frame or a tibble going in as the first parameter. It always returns a new data object, so it never updates in place. There's, like, R is a nice little functional language, so it gives you something new. So if you want to save that, you make sure to assign it somewhere. And it also, you specify columns of your data sets as these unquoted strings or symbols. It's kind of like the technical term for it, but basically you're just kind of putting the bare word name of the column exactly as it appears in a lot of these expressions. So, for example, starting with the first basic verb of just filtering. So here's what the call looks like, right? So it's filter. Again, the data that you're using goes in as the first parameter, And then you have some sort of expression that's telling how you want to filter your data. So there was a column called destination. I'm looking for all these that are going to DTW. They're coming this way. And it has the little logical operators that you can combine. So I'm also looking at all of them that came to Detroit in June. And that's going to subset that data frame that way. Now, again, filter is not magic. A lot of times people using base R might do something like this, using indexing. Again, you're just kind of having some redundancies of having to repeat the flights and then having this comma what, like, you know, maybe not exactly obvious what that is, but it works nonetheless. And also base R also has a subset function, which works almost exactly the same as filter with the same syntax. But again, you can do this stuff in base R, but filter is going to have some other properties that we'll talk about later that are nice. But that's basically how it works. Another verb that you might be interested in, again, is just select. So select, again, it takes the data frame that you're interested in, and then you just put a bunch of commas, or a bunch of column names after commas, and you just pull out those particular columns. You can exclude them by putting a little minus sign in front of them. And you can select ranges, which is also nice, by putting a little colon between them. So it'll take all the columns that are logically, or that print out between month and departure delay, it'll select all those for you. It also has a lot of really other kind of nice selection options. Again, you can get to like the help for any of these functions in R by just typing a question mark and then the name of the verb. So question mark select shows a bunch of these examples. But here you can select all the columns where the name starts with D or ends with time, contains ARR for like arrival, all those that don't start with D. And then you can also rearrange them. So the order that you put them in is the order that they come out of select. So you can say select flights. I want the flight column first, and then just give me everything else after that. So there's little keywords for everything. So there's a lot of functions to help you select names of columns should you be extracting those.
And if you use the everything syntax, it deduplicates columns?
It will not do flight again.
Okay.
Yeah, so it'll do everything that's not already been specifically requested. So now here comes the more kind of fun part of Dplyr, is when you start combining verbs together, and what does that start to look like? So, you know, one way of doing it would be to go ahead and filter your data set, save that to a new variable, and then do your next verb on that filtered data set. Again, filtering itself doesn't change the flight's data at all. You need to save that new transformed object to somewhere. So you could do this. Or maybe you nest these calls. So first we're going to filter, and then we're going to select the carrier from this filtered object. Now, both of these are possible, but they're maybe, you know, you have to create a bunch of extra variables, or you have to like get really long expressions if you're doing a bunch of things. So what Dplyr is kind of championed, and it's actually the magrittr package specifically that implements this, which is part of Tidyverse, is this kind of piping notation. So similar to like when you do stuff at the Unix command line, you can pipe the output of one program into the next program. So you can find Apple in this file, maybe just grab the first 50 lines that have it, cut out the third column, sort it, count it. The pipe operator works a lot like that with Dplyr, allowing you to change a bunch of nested expressions into a series of statements. So for example, if I'm calling the function C on X, then calling B on that, and calling A on that, I can now use this pipe operator to start with some value, pipe that into the C function, whatever that output is gets piped into the B function, and whatever that output is gets piped into the A function. So these are pretty much syntactically equivalent, but this one tends to be a lot easier to read, especially when you read this pipe operator as just saying then. So we could say that we take the flights data, we filter it, and then we select it. So this this expression here is equivalent basically to the same output that would have been generated by those two statements previously, but it becomes a little bit easier to read. So for the rest of this talk, I'm going to basically use it in this form. We're going to anchor with our table first, and we're going to be piping it into these extra columns. So again, this pipe operator is not specifically used for Dplyr. You can use that in any functions that you want. All it logically does is it takes the thing that's on the left side and plugs it in as the first parameter to the thing on the right side. So that's why all these functions are kind of empty, because basically we're just, the piping operator is just plugging them in as the first parameter. Now you do have control over where it goes if you really need it, but that's basically how the piper works. So yeah, yeah.
Is there a way to shortcut this pipe thing? Because I think that's, maybe I don't use it enough, but I think it's Yeah, I kind of sucks typing this %.
Sure. No, there's no shorter way to alias it for the most part. RStudio has a Control-Shift-M, which is a nice keyboard shortcut for just popping that pipe operator in there, whatever IDE or text operator you might have. It has to do mostly with the weird way. So this is, again, it's not part of base R, it's an add-in package, and the only way you can add infix operators that you want to define is to have these 2% signs on the opposite side. That's the only thing in the R parser that'll put it into the right syntax tree arrangement. So yeah, there's no way really to shorten that pipe. But again, most times it's pretty easy to put a keyboard shortcut together to make typing it painless. So yeah, now just continuing with the other verbs. So we've talked about 2 verbs specifically. We talked about how you start combining verbs. So now I'm just going to talk about some more verbs. So arranging, again, it's just a way to sort your rows by however you want to sort them. And you can use this descending function around column names to just do the reverse descent or ascending that way. Or you could even put a minus sign, I guess. The descending. I think minus sign will only work with numeric values because it actually does the negative value of that. But so if you want character values sort of descending, just use the descending operator. And then you can, you don't have to create new variables that you want to sort on. You can put complete expressions in there. So if you want to, look at the difference between the actual departure time and the scheduled departure time, and then figure out where the biggest delays were, you can always put that as an expression there. So that's just kind of how arrange works. Now we're getting into more powerful verbs. So instead of just kind of subsetting and grabbing things out and putting the order, now the power of mutate allows you to create new columns from existing columns. So this is where a lot of kind of the summary information happens, and it's very useful. So say I was interested in figuring out which flights had the best overall average speed across the whole entire journey. So here's what I can do. I can now do a mutate, and I can take, in this case, airtime is in, no, it's, what was I doing, miles per hour? I guess hours? No.
They're coming minutes.
It must be in minutes, yes, thank you, in minutes, yes. Minutes, so then I get the hours. Okay, so I take the total flight in the distance divided by the number of hours, and essentially I get a speed in miles per hour. So essentially with the mutate, you give a new column name, you put in equals, and then you put some expression that has other existing column names in it. And it gets evaluated in the context of your data frame. And now what pops out here is essentially a new data frame that has this column added. And now we can arrange based on that calculated value that I have. And then I can just select maybe just the flight number and the speed for all these things. So I can just see all the speeds in a list there. And remember that this new thing doesn't get saved anywhere. It just prints to the console if you don't do anything with it. So if you want to save it, make sure at the beginning of your chain, you assign this to a new variable somewhere so you can use it again. Now, the other interesting thing, which sometimes can be tripped up if you're not expecting it, is that these values that you create along the mutate can be used by the next thing that comes after each of these commas. So you need commas between each of these assignments. But here you can create a new column, the distance in kilometers. I did miles per hour the first time, but say I'm interested in kilometers per hour. Here I can do a translation, and then in the hours I can create this separate variable here, again, to make it more clear that I'm calculating the hours. And in the kph, I can use these two columns that I've created in previous steps to create this new expression here. So they're created kind of in the order that they appear. This does mean that you can overwrite values. So if I were to have assigned this airtime divided by 60 back to airtime, there's no way to get to that original airtime anymore. It kind of gets overwritten. So just make sure that when you're doing this, that's your intention. So the order when you put those in does matter a lot. So again, that's just a little note about that. So mutate never changes the total number of rows that are returned. It essentially is just adding a column and keeping all of your data. So there should always be just a new column it never changes the number of rows. Now summarize tends to collapse rows for you. So what it's going to do, it's going to create a new column, but it's going to apply some function to all the values of that column and give you some sort of just summary for that. So you want to use functions that take a lot of values and get them down to 1. So for example, mean. I can take a mean of many numbers, and in the end, I get just one number. So in this case, there happens to be some null values in the arrival delay if there's no delay, or missing values, I should say. But I was trying to find the average length of the delay. So I take the flights, I just filter out those that are missing, and now I use summarize. And I can get the average arrival delay by just taking the mean of that column. So instead of getting, whereas before we were calculating the kilometers per hour speed of every row, we just added a new column. Now in the end, I'm going to get a table here that just has one row in it that has the mean across that entire column. So you can use a variety of, again, base R functions. There are a few that Dplyr adds. Dplyr adds things like n just to get the number if you're interested in counts, or the number of distinct values, or the first or just the last for some reason. And then you can use all the standard base functions, your mean, median, variance, standard deviation, min, whatever, whatever kind of summarizing functions you want to use. You can write your own, it doesn't matter. Just any function will work that takes a list of values and returns one value. So, collapsing that whole table down to just one row gives you the average maybe across all carriers, but sometimes you have groups that you're interested in and you want to see how the summaries differ by each of those groups. So that's where this group by function comes in. And it's really, I think, the thing that makes Dplyr much nicer than most base functions is this very simple kind of grouping by verb, where you don't have to do a bunch of splitting or subsetting or the AVE function. I mean, you can do everything that's kind of group aware. And functions like mutate and summarize are performed within each of those groups that you defined. So, for example, before we calculated just the overall delay, but now we want to know the delay by carrier code. So again, we filter out those missing values. I add a group by carrier, and then my summarize statement, again, it is the same thing. But because I've done a group by, that column is preserved, and I get a summary for every unique value in that carrier column. So it allows, again, you can do more complicated expression, you can group by other variables, but essentially these group bys kind of sneak their columns along and summarize these. So now there's only one row for this carrier code E9. It's all been collapsed via the mean function that we described. So mutate, again, will not change the number of rows. So functions like max will return the max for each group. So that means, if I wanted a column where the max departure time for that carrier was also on the row, so I could see maybe the difference between the maximum arrival delay and each individual arrival delay, I can use mutate, and that'll, within that group, will return that same value for every one of the rows in the group, whereas summarize collapses. Does that kind of make sense? Okay. So a group by plus mutate. So this is, just going into that. So what I was talking about. So we filter out those that are missing. We're grouping by carrier. And now we're doing a mutate so that we're calculating the mean arrival delay for each carrier and then selecting just 3 columns here so it prints more nicely. So we can see now I don't just have one column for the, I believe this is United Airlines. I forget my carrier codes. I'll show how to merge in that information later. But now this same average arrival delay is returned for each of those columns. So I'm still getting all 3,200 and 7,000 rows, but again, within that group, that column's the same. It's been summarized and just repeated. Merging data. Sometimes you have data in one table that refers to some code in another table, and you're interested in what that code means. So if you've used SQL before, or SQL, there's a lot of those same types of rich joining operations are made a lot easier with Dplyr. In base R, you have just like the simple merge function. These in R, it's just a little more clear what all the join functions are. But again, just going back to this example, I got all these average delays with all these codes, and I didn't know what the codes are. It just so happens that in this same database, the NYC Flights 13 that you can download, there's also a table called airlines that gives these 2-digit codes to some sort of human readable format. So now what I can do is, again, up to these first 4 lines of the exact same code we used before, and now I can left join airlines. And now it's going to essentially add this name into the output. And what it does, when you just do left join without any options, it just looks for matching column names. So in both cases, I go back again, this airlines table had a column called carrier. The summary had a column called carrier. So it just implicitly matches on all matching column names. And now I get this information. So, oh, yeah, so AA is American Airlines, AS, Alaska Airlines, information like that. So left join is just one of the join options. So in case you haven't done a lot of joining before, just to give some visualizations of what all these different types of joins look like. For example, I'll talk about, there's the 4 simple join types are an inner join, a full join, a left join, and a right join. And to illustrate, I'll be using this sample X and Y. So let's say that there's this key column, this numbered column, and then there's these values X1, or X2, X3, Y1, Y2, Y3. So what's going to happen is if I do an inner join, it's going to look at essentially the key column, find only the ones that match, and return those matching rows and keep them together. So because there's no 3 in Y and there's no 4 in X, those kind of disappear. So the inner join matches things up exactly, so we get a little subset of that. Left and right joins actually matter which data is on the left and which one's on the right. So if you say left, it preserves all the values that are on the left side of the operator, essentially whatever parameter you pass in first, or if you're chaining it, whichever thing has been piped into you. So in this case, because we do a left join and X is listed first, I keep other rows from X. So despite the fact that there's no value for 3 in Y, I still get a row for 3 in the output. And right would just flip that. So that means I want to keep everything on the right. So there's no 4 in X, but I get a 4 in the output. And values in R are just kind of inserted as NA value, kind of just the default missing value. And a full join now keeps any row that was missing from either of the two. So it just keeps all the rows, matches them up when it can, and if it can't, preserves the values it does know and just sticks in NAs for those. So different useful join types available to you. There's also kind of non-merging joins, which are very useful. So semi-join basically allows you to filter one table with the values of another. So instead of like merging in new columns, it just allows you to subset the original table of interest. So if you have you have maybe 3 different fields and you want to match them on 3 different fields here and only keep in the subset, if it's genetic data, maybe you have chromosome, position, ref, or something in 2 tables, and you only want to keep this subset of those positions, you can do a semi-join, and that'll subset that full table that maybe has all the information to that smaller table that you have. An anti-join just does the opposite. Instead of keeping the rows in your smaller list, it just deletes those rows in the smaller list. So it does a lot of the things like merge, but doesn't actually change the columns. So useful for subsetting or filtering. So by default, it looks for matching column names and just keeps those. So in most cases, if your columns are nicely named, that's wonderful and exactly what you want. But sometimes that's not exactly what you want. In the case of the flight information, there's a, I guess, yeah, maybe I should pull it up a second just to show a little example. So if I pull up Dplyr just in R, I'm going to load up our NYC flights 13. Oops. Need some parentheses. Oops, and it's hard to do, type over your back. Okay, so now I have my table. So I have my flights information, which again has all of our flights, and we also have the planes information. So the planes give some information about essentially what type of airplane was used on the flight. So each of these airplanes have a tail number with a year and a manufacturer and a model. So this year is actually like the year the plane was manufactured or put into, I can't remember if it was manufactured or put into service. But if I look at the flights table, I also have a column called year, and this is actually the year that the flight took place. So, but it also has a tail number column here to show what plane we actually went on that journey. So if I do a join between those two, I'll do an inner join. The flights. Inner join. So I get a little note that it's actually joining by year and tail number, and in the result, I'm actually only getting the planes that were put into service in 2013. So I'm getting 4,630 rows in the output, which isn't the type of join that I wanted, because that year means two different things in those two different tables. So what you can do is actually specify what column that you actually want to do the joining by. In this case, we only want to join on tail number. So if I put that in, it does the join again, but this time I now get 284,000 rows. So it's ignoring that, and well, all the flights happened in 13. Yeah, unfortunately the year of the Y, so this year column gets merged in. It gets merged in with a suffix of like that X and Y that it remembers. So it still preserved that other year value, but now, yeah, there's values that aren't 2013 in there. So just keep that in mind when doing merging. Sometimes the default behavior is great, and sometimes you need to override it. So there's a lot of options for specifying the two different column names there.
So you can specify the column names if they're not the same name?
Yes. Don't know if it has a great example, but what it's going to look like is it uses let's say that it was called TN in the other data frame. So what this is going to look like is you basically give it the X name and the Y name and match them up. It uses named vectors. It's an unfortunate kind of side effect. It's not great syntactically when you're trying to program on it, but it uses kind of these named vectors where you give it the name of the vector is actually the table, and then the value of that named vector is the name in the other table, and you can link them up and put them all together there. So it is possible, yeah. So Dplyr, again, is made for data mangling and wrestling, so it has some other kind of just useful functions kind of in addition to the primary manipulation verbs. There's distinct, so if you want to filter out duplicates, you just tell it which two values you are interested in, or which columns you are interested in, and it only returns the unique combinations that actually appear in your data for those columns. You can use a count, which basically kind of does like a table in base R. It just looks at all the carriers and counts the number of rows in your table for each of those. It creates a new column called N for you. I can do that in a second. Just oops. Right, it's just, that just gives the overall counts of rows. If I wanted to maybe, group count by the carrier, then I can just get a little N for each of those. So, nice just a little summation. You can randomly sample a certain number of rows kind of from each group. So if you want to randomly grab 3 rows from the flights table, you can do sample N and, get 3 random rows. So in addition to just kind of summarize and mutate where you specify all the columns, sometimes you want to do the same thing to a bunch of columns. And so there's 3 kind of different options. Summarize all and mutate all will apply the same function to all the columns. So if you want the mean of every column in your data frame, you can get that. Summarize at allows you to specify which columns you want, and you do that in a little VARs with. So I could summarize all the variables that end with time and get the mean of them. So flights is actually getting piped in as first parameter. I'm specifying all the columns I want, telling it which function to apply to those. You can pass in additional parameters to this function as well. In this case, because some of the times have missing values, I tell mean just to ignore missing values, just to drop them. So here I can get the average time for every one of those columns. And then summarize and mutate if allows you to just kind of do conditional, do a test over the column itself and decide whether or not you want to summarize or mutate it. So if I were to summarize all and take the mean, well, there's some character columns it doesn't make sense to take the mean of a character column. So in this case, I can actually say only if it is numeric do I want to summarize it. And additionally, I don't want to display one function, so I can use this funds operator to specify more than one function. I want the mean and variance. And also, please ignore all the missing values. So it's very expressive in that sense. So you can only do certain things for maybe numeric columns or categorical variables, things like that. And the two helper functions here are vars, which you use when you want to specify more than one thing, because if you put a bunch of commas in, it's going to kind of interpret it as extra parameters, and it needs to know that these are all columns that you're interested in. And same with functions. If you put extra commas not inside the functions, it's going to turn them as extra parameters to summarize if, and not just kind of extra functions that you're interested in running. Other useful functions, it has a lead and lag to get a value before or a value after. Kind of just shifts your array one to the left or one to the right if you're trying to match up with a value that came before or after. It has a useful coalesce function, which is if you use SQL, it's just like the coalesce operator there. You can pass in these lists of vectors, and for each row that it goes across, it'll return the first non-missing value. So if you have different columns, some have missing, some don't have missing, and you need basically just the first non-missing value in any of these columns, you can use the coalesce operator for that. I'd mentioned before, and distinct, useful for counting, especially in like the group by scenario. So if you're interested in the number of total number of flights by each plane, you can get the total number of flights. And if you're looking for the unique routes, because some planes fly the same flight number multiple times, you can get the number of distinct routes versus the number of total just flights they took. Another useful function is recode. Allows you to easily change values in a list if you just have one value that you want to change to a different value. So in this case, letters is a built-in vector in R. 1 through 5 just returns A, B, C, D. But in this A, B, C, D, E, in this case, I just want to change the value B to the word boo, and basically it does that. Instead of doing a bunch of kind of like ifs and subsettings, recode can be very useful for changing one or more values just to some other value. Case when is a great alternative to maybe if-else if you have a bunch of conditions that you want to apply. It's basically like a switch statement in other languages. It does have somewhat unusual syntax when you're looking at it. The idea is you put some expression that you're testing for. So this is looking for, I have a value of x here, it's just looking for all the values of x that are evenly divisible by 35. This little modulus operator is the double % sign, and basically evenly divisible by 35. It uses the formula syntax, so that's where this wiggle's coming from, and it's saying what's the value that you want when that particular case is true. So it's going to go down this list that you apply to case when, and it's going to stop when it finds the first true statement. So that's not true. It's going to check, is this evenly divisible by 5? If so, spit out fizz. If it's evenly divisible by 7, spit out buzz. Otherwise, I kind of have a catch-all here. Just keep that value the same. And in this case, because I started with numbers, it's turning into a character. So this case when expression allows you, again, to do, if it's not just a simple recode, if you have a bunch of conditions that you're interested in transforming, here is what the output that looks like. So all those that were divisible by 5 get changed to fizz. Those that were divisible by 7 get changed to buzz. Those that are divisible by 5 and 7 get changed to fizz buzz, which, oh, do I not? Yeah, I didn't go up to 35 there, but that's what the output would look like if you looked at the full 50. So sometimes you want to combine the information. Well, there's two different ways of combining information. We already talked about merging, which basically looks at two different data sources and tries to line up columns across them. Sometimes you want to just stack one data frame on top of another, or maybe just stick two side by side together, stitch them up if they have the same number of rows already and you're sure they're in the right order. So there's bind rows and bind columns. So bind rows just stacks things on top of each other. Bind columns, puts them side by side and stitches them together. These are much more efficient than using like cbind or rbind in R. With base R, they're much better at growing data sets and not mangling different data types. So they're great ways to just, again, put together things, especially bind rows. There's also things like, intersect, union, and set diff to look at basically again, common elements between different data frames, if you're looking kind of like filtering. So these are just kind of maybe alternatives to actually doing a full merge if you're interested in just getting differences between different vectors. So that's a lot of the basic verbs in Dplyr. Are there any kind of questions about those that we've talked about so far? Yeah.
Okay, so maybe you're gonna cover that
Okay.
or not. But Dplyr changed their sense. So before they used to have like whatever function, they have the function underscore
Yes.
where you could give a string instead of the name.
Yes.
So now they abolished that
Yes.
and they're using Erlang. So are you gonna cover
Yes,
that?
that's actually, that's the next
Awesome.
section. But we're going to talk about how to program with that because that's very important. But yeah, just any other questions about just the basic verbs? Yeah.
Can you view the pivot table?
So the pivot table is actually comes from another package in the Tidyverse. I think like Tidyr is the one that's better for kind of breaking out values. Yes, so that's one thing maybe Dplyr on its own isn't the best at. But yeah, there's another package, and yeah, it's a little more it's a little more work to explain everything that one can do as well. But I think Tidyr is the better solution for that than Dplyr itself. Yes.
For back rows, does it just simply stack these two together, or it has a like column matching?
It'll stack them up, but it'll match the columns that are named the same. So the columns should be named the same. If the columns are different, it's going to import. It'll put a value of NAs for the one, a value of NAs for the other ones where the columns don't match up. But it will match on column name.
But does the C9 do that?
I don't think so. I don't think so. Yeah, it has. Yeah, it's been a while since I've been down that path, but okay, great. And then now we'll talk about. So these commands are great if you're just writing them out, and maybe you have a little R notebook that you're working on. It helps create very readable code, but sometimes you want to create functions, and that's where getting into Dplyr is a little. It's a little bit trickier than maybe you would like. So the idea is, I create this little code chunk. I want to group by carrier, and I want to get the average arrival delay by carrier. But let's say I'm also interested in running the same kind of operation for multiple different columns, and I want to just group by something different. Well, if I kind of naively write this little function to take in a column, now I say flights, I want you to group by this X, and then calculate the average arrival delay. When you go to run like F and just try and pass in carrier like you would here, you get this error that column X is unknown. And the reason is that we always pass in column names as basically bare keywords, which is exactly what a variable looks like in R. So in this case, it doesn't know that X is a variable. It thinks that that's a column name. There's nothing to clue R in that, oh, hey, I'm actually a variable that you need to resolve first before you actually try to run the group by. So that's where things get a little bit confusing. And in old versions of Dplyr, they're using this underscore. But now with this new Erlang syntax, they're introducing things called Quosures into R, which is a Quosure is like a quoted closure. It has a symbol, but it also has an environment attached to it. So here's two options for rewriting your functions and what it looks like. So Quosures can be created using this QUO keyword, and basically this is now saying instead of just having the symbol carrier, which looks like a variable, I'm saying that this is an expression that I'm going to want you to evaluate at some time later, but don't try to look up what the value of carrier is now because it doesn't exist. And how I tell R to expand that later is using this double exclamation point or the bang bang operator. So what this does is it takes this Quosure that you pass into here and it expands it, it double bangs it, so now it's basically like you had just typed carrier into that place. So this is one way to kind of rewrite that function, is you have to create some sort of Quosure and then you have to expand it at some point later in your expression. Another way, maybe a little cleaner way to write this, although it depends on what you like, is if you want to be able to just pass the actual name to your function instead of having to explicitly call quo on it, nquo can take whatever was passed to your function and create a Quosure from that. So that's going to create the Quosure of, again, just this carrier thing by passing it into your function. And again, you expand it with a double bang to make it into that X value. And you can insert that there. So the double bang or bang bang can be used essentially anywhere you're using kind of a single column name. I could also change the name of the column that I'm taking the mean of by having another parameter. I can use a double bang y there if I want to pass in a second thing. But that's now how you kind of insert variables into R. The only other catch is that you can only use normally you can only use the double bang on the right side of an equal sign, or where you're not using an equal sign at all. The equal sign in R has like this different, it's actually naming parameters, so it doesn't have the same kind of variable options that you use. But Rlang specifically has also created this :equals operator that allows you to then rename the left side of an equals operator where you normally can't. So if you wanted to, in your summarize, dynamically create the name of the new column you're created, because the Dplyr rules that has to be on the left side of an equal sign. So we have to do a little bit extra work. So here's what we do. If I walk through this step, basically I'm taking this function h, and I'm passing in carrier. I'm creating a Quosure from that carrier, so I'm kind of capturing that symbol so I can evaluate that later. And now I'm creating an out name. So I'm taking this Quosure. If I want to get the string value of it, because I want to paste this to create some sort of string name, I use quo name, so that can actually get the string carrier basically carrier like in quotes, and I can add that to delay with an underscore in between. So that's creating this output name, carrier underscore delay. And this is all as a string here. So, and now I'm grouping by that column. I'm going back to that original Quosure. And now I'm using that out name variable that I created here. I'm using the double bang to expand that into the expression. And again, you just need the :equals for that, and then you just continue with the rest of your expression. So it gets a little more confusing. Again, those underscore functions that you may have used temporarily before have been deprecated or will be. But this is kind of how you need to program functions. So writing functions with this Dplyr looks a little bit messier, but it's really a good idea because, again, if you can create some sort of verb that describes exactly what you're doing, you can express that very easily in some sort of pipeline that other people can use. So there's, yes?
Is this working already for ggplot?
No.
Okay,
yes.
so
So ggplot is maybe the black sheep of the Dplyr family. It's the oldest one. It uses pluses instead of the piping operator to do things, and I think they've declared there's no intention to actually change that at any point. It does not yet work well, but I think Quosures will be working with ggplot, but it's as of today, it's not available yet.
It's the AES underscore string.
Still with the AES underscore or AES, Q. Yeah, there's a variance on the AES. You still have to use those for ggplot. So yeah, all these functions I talked about are all in the data wrangling cheat sheet. It's a wonderful cheat sheet that RStudio put together. I recommend when you're learning Dplyr, you print it out, just put it out of your desk. If you just search the RStudio data wrangling cheat sheet, and it's actually available. I think it's right in RStudio. I think they have the cheat sheets. Data transformation. Just to link you right to that. Again, a very useful summary of all the functions, and maybe some I didn't talk about today, but just really helps you kind of, again, visualize those and remind you what's available to you when you're using Dplyr. So that's basically my talk today. Thank you very much, and I'll be happy to answer any questions.
There's a question about
Yes, I do think that, again, when you're writing code, it is much easier to read the steps. So for that sense, and because it also expresses what your intention is more clearly, instead of trying to understand, again, the square braces and the dollar signs, I do recommend teaching Tidyverse first. I think it is like if you're going to teach if you only have one day to teach someone R and you want to give them useful skills in it, I think it's great. I mean, ultimately, if you're going to be using R for a long time, you do need to understand more how the base functions work, especially if you're going to be debugging code from other packages. Using Dplyr code in your own package is actually kind of not fun because of the way all the column names look like variable names to the checker that verifies your package is good to go in CRAN. You have to do a lot of kind of weird escaping of things in order to get it to work. So it makes it really great if you're writing your own code. It's not so great if you're writing stuff for a package, which is like the only caveat to like really diving down into Dplyr. But again, I just think it really helps people get productive more quickly, especially when you combine that with maybe ggplot2. Like if you have those two things down, there's just so many things you can do in R. I mean, super fancy data analysis, but at least the visualization, the steps of exploratory data analysis are made so much easier with Dplyr. Yeah, great.
Any other
And then,
questions?
yeah, if you have any other questions or things that come up, I did push my email address down to the slides. It's just mflick@umich.edu. I'm happy to answer questions about Dplyr as they come up, or anything else. I feel I learn the most about R when I'm answering other people's questions about stuff I've never thought of before. So it's very fun to do that. So thank you very much.
Thanks.